Good afternoon, everyone. Welcome to our third and last day of OSLC Fest. It has been a fantastic 2 days. We've had a lot of I was planning to go without a webcam, but hi, everyone. I'm excited to have the third day, closing with some of the best industrial cases and even more inspiring talks, going to some cutting-edge applications. My name is Andrew Berezovsky. I'll be your moderator for today. As before, please open meet.ps/OSLC Fest to join the Q&A and polls. And our first speaker today will be Leonid Makrushin. But before I go, I would like to give a warm thanks to everybody who made this event possible. Axel Reifein, Jim Amsden, Jad Al-Khoury, Nick Crossley, and Gabriel Fernandez. Thank you so much. And let's do it. Leonid is a principal researcher at Ericsson Research and a passionate promoter of logic programming. Today, he'll present you an open source Prolog SDK, and I'm pretty sure he will try to share his passion for Prolog alongside. Before his presentation starts, Leonid has prepared a poll, which I'll start right now. Please vote throughout the talk, but also feel free to change this vote. Hopefully more and more of you will change from no to yes towards the end of the talk. Leonid, the stage is yours.
Thank you, Andrew. So, Prolog OSLC SDK. First, before I start, one slide about myself. So I'm a principal researcher, as Andrew said, in Ericsson Research. Ericsson is a company that is enabling communication for more than 140 years. So it's a little bit of a weird company to enter the OSLC stage, but regardless, I'm coming from research, so I'm like academia. My fields of interest are artificial intelligence, machine reasoning, basically the symbolic part of AI, knowledge representation, and you see where it's going. So OSLC, it's a very related field. Part of my work, I'm doing prototyping and demos of new concepts, and I've been with Ericsson since 2007, and before that I did some Java programming, and all in all I probably did roughly 10 years of Java programming. And when artificial intelligence became a hype, I switched to Prolog, and you can see that logical programming is much more related to artificial intelligence. So Prolog became my second favorite language, and I've been with Prolog for roughly 5 years already. So as many of you probably associate Ericsson with Sony Ericsson, used to be such a company producing mobile phones, but Ericsson is mostly dealing with producing equipment for operators such as base stations, antennas, radio modules, and so on. And you can see here on the picture the progress that we made since 19th century until now. So the picture on the bottom in 1890 is the tower in Stockholm, which is a telephone switching tower. You see all the wires from all the telephones go to this tower, and switching happens there. Nowadays, everything is wireless, of course, but still requires a lot of innovation and research in the area. So we are looking into how artificial intelligence is going to help making these products more intelligent and efficient. So going to Prolog. Why Prolog? Okay, Prolog is a programming language. It's been there since 1972. It's based on first-order logic, but mostly it's very appealing because it's ridiculously simple. So there are no types, even though there are typed Prolog implementations. There are no classes or objects like an object-oriented programming, but there is also object-oriented version of Prolog, which is called LogTalk. There is typed version, which is called Mercury, if you're interested. But I'm mostly dealing with a pure Prolog and the pure implementation. One of the most popular open source implementations is SWI Prolog, which is implemented by the guys from University of Amsterdam. So the language is ridiculously simple. So you only have things like atoms, which are like constants, variables, terms, and clauses. So clauses combine terms into rules. Then you have logical and or, and then you have unification. So that's it. So that's the whole language, basically. You can learn it in one day. But there is a lot of functionality under the hood. So it has a very rich implicit language features such as search, indexing of arguments, which is similar to hash tables, DCGs, which stands for definitive closed grammars, where you can specify language grammars easily inside the language directly. And once you specify the parser, for example, for a language, you get a serializer for the same language for free, because you can run this DCG in both directions. There is meta-interpretation facility where you can write interpreters that interpret your Prolog programs with the different semantics. There is a library about constraint solving, constraint propagation over different domains such as integers, booleans, reals, where you can solve very interesting problems numerically. Of course, there is a garbage collection. So there's a lot of these functionalities behind the hood, which are not visible to the programmer, but which provide all these services. So your program becomes really refined. It only keeps the business logic. All the boilerplate is hidden. And one of the libraries that SWI Prolog implementation comes with is Semantic Web Library. And this is one of the reasons why I chose Prolog for implementing OSLC SDKs, because Semantic Web Library provides a native support for RDF and RDFS. So you can directly work with triples in your store. It also contains the store itself. So the store is an in-memory structure that you can work with from your program directly, like a tree or an array. So you don't need to install any external database. You don't need to deal with Sparkle interfaces. You can just work directly with triples in your store from the language. The implementation of this storage is done in C, so it's very efficient. It can handle roughly 4 million triples per gigabyte of RAM. So if you put it on a big machine, you can handle quite a lot of knowledge in a single node. On 32-bit architecture machines, the storage is limited by 15 million triples, but on 64-bit is just amount of RAM that is the limit. It supports transactions, it supports indexing, it supports persistence, so you can save the state of your knowledge base to the disk and read it back. Another nice feature of SWI Prolog is the Cleopatra web application server. It's written in Prolog. It supports packaging of your applications into packages and installing them and uninstalling them from the server. It has a Sparkle endpoint already implemented, so other applications can use it. And it has a web UI through which you can explore the contents of the knowledge base and perform some simple actions. So let's see what the SWI Prolog can do out of the box. So when you install it, this is what you can do. You can assert a triple, say my class type, RDFS class, and it asserts. So then you can read it, of course. You can ask if there is such a triple that has a subject my class, predicate type, and object class, and says true, yeah, such triple exists. But you can also replace some of these arguments with variables. Variables are capital letters here, so X instead of a subject. And then you can ask what are all the subjects that have type predicate that points to an object RDFS class, and it will give you multiple results. So X can be my class, or it can be all configuration or discussion, so on. If you want to have a transaction, if you want multiple modifications to the knowledge base come as a single atomic operation, then you can wrap it in a transaction predicate. And then all of the internal asserts will happen at once. So they will either happen, all of them, or none of them, if some of them fail. You can, of course, load external files. You can say RDF load, give it a file name, give it a named graph, and it will load the content. It supports multiple serialization formats like XML, Turtle, and triples, and so on. It has also RDFS reasoning, basic RDFS reasoning. You can, for example, ask for a subclass of a certain class. But here you can see in the second example, I put X as a second argument, not the first argument. So I'm using subclass of relation to figure out what are the superclasses of a class that I know. So you can, since Prolog is a relational language, so all the expressions are relations, and you can run them in both directions. You can also utilize literal indexing. For example, here I say, I want to find such subject and predicate where the object is a date, and date should be greater than 1st of January of 2000. And the storage will take this constraint and use a literal index to quickly find triples that correspond to it. Right, so the motivation behind the OSLC SDK for Prolog. So you can see that it's very good library there that you can use to handle triples, but would be nice to have such an SDK that would allow you to work with resources, so basically sets of triples in a single operation. Then some kind of REST API through which you can communicate the knowledge would be a next good feature. Some kind of client API where you can make queries to the remote resources, and some kind of validation of the resources, right, according to shape. So all of these requirements basically at the time of implementation, which was 2017, 2018, boiled down that OSLC Core 2.0 was a guiding document for implementing such an SDK. So this is the architecture of the SDK. At the bottom you have SAA Prolog with all the libraries like HTTP, support for HTTP, UUIDs, RDF, and knowledge base through semantic web library. On top of that, there is a Cleopatra application server that provides a Sparkle interface. And on top of that, you can install applications, basically, which are packages. And one of the packages is the OSLC SDK itself. It provides a REST interface externally to the clients, and it provides API internally to the custom OSLC services that can be implemented using this SDK. What you get in the package for the Cleopatra application server, basically the package is a structure of folders which can contain different types of objects. So it can contain knowledge directly in text files like XML or Turtle that will be uploaded into the knowledge base when the package is installed according to the manifest. It may contain Prolog code that implements logic of your application. Can have like resource handlers, configurations, libraries, and so on. And it may also have a web view, so something that exposes your application through the REST interface, and the application server will take care of serving this web view. The package itself contains a metadata, and the metadata is also an RDF document. It describes who created the package, what is the repository of the package, what other packages it depends on, and so on. So if we go inside the OSLC SDK, we chose to create a single format for the URIs of the resources. So this is what it looks like. So the resource has, of course, an authority part, which is your server port. And then there are two segments of the URI. So the first segment denotes the prefix. The prefix is taken according to the prefixes that are registered within the semantic web library. And here you can see the example table of the prefixes that can be registered there. You can also register custom prefixes as well. So the prefix takes the short mnemonic, for example, it takes RDF for RDF namespace. And the second segment is the resource, is the name of your object within that namespace. The resources may, of course, contain sub-resources. And then there is an optional part, which is a query. And currently, the SDK supports OSLC properties and OSLC prefix queries. Those were defined in OSLC Core 2.0. And you can do like normal OSLC CRUD operations with it: get, post, put, delete. And it supports also put with if match header. So if you first fetch the resource, you get an e tag header containing the hash of that resource. And if you modify this resource and put it, then the if match header must contain the same hash. And if hashes match, then the resource will be updated. So at the at the bottom right, you have the example curl query. So you can say, give me a resource, localhost :3020/rdf/type. So I just want to get the RDF type resource, and I accept text turtle as a serialization format. And here you see the response from the Prolog system. So this was an external API. So internal API allows you to manipulate resources from your programs. So we provide functions to create resources, to query resources, to copy resource from graph to graph, and also delete resources. And then you can register also handlers. So handlers contain the method part. So which HTTP method they handle, get, post, put, delete. And then it takes 3 arguments. So first argument is the resource, which can be given as a prefix name notation or as a wildcard notation, for example, if you want to handle all the resources from a certain namespace. Then the handler itself. This points to a Prolog predicate that implements the handler. And at the bottom, you see the example of a handler. So the handler gets a context as an argument. And the context contains the IRI of the resource that was requested, details of HTTP request. And then if the resource was, for example, send a post request with a graph with a kind of a RDF document in it, that document will be parsed and given in the context as a request graph. So you can, in the handler, you can explore that request graph. And if the handler wants to respond something back, it can write to the response graph. And if the response graph at the end of handling is not empty, it will be serialized according to the accept header and sent back to the client. And the third argument, which is optional, is the priority, because you can have multiple handlers that handle the same resource, but they will be called in the priority order. And if a handler with a higher priority didn't handle the resource, it returned false, then the handler with a lower priority will be called in the row until some handler that handles the request completely will handle it. So there is a default user priority 1000 if you don't specify any priority, and the higher the number, the lower the priority. So the priority 0 is used by the system, and it implements all the default handlers. So once you install OSLC SDK, you will get all the default handlers that handle like returning the resources, updating the resources, and so on. But you can also implement custom ones. So here's the Hello World application. We create a virtual resource. So instead of just returning the resources that exist in the knowledge base, you can also create virtual resources. So you create them on the fly at the time of the request. So here we register a handler of the resource, which is called OSLC time, and it will return the current time. So every time you post that query, it will return a different object with the current time. So we register a handler OSLC get. We say that we will handle OSLC time resource, and get current time will be the handler of that resource. And then we get system time, and then we create resource using the internal OSLC SDK API, and we put it in the response graph. So here you can see an example request. So we can say, get me OSLC time, I accept text turtle, and you get the document, which is an OSLC time resource, which has type OSLC time, and then it has DC terms created pointing to the current time. So this is as simple as it gets. In addition to that, OSLC SDK provides a Cleopatra UI extension where you can see all the resource shapes that are registered. So all the shapes are used in copy, create, and query operations. So some of these operations work with resources that point to a shape that they comply with. These shapes will be validated. And if validation doesn't pass, it will throw an exception, which an application may catch and handle accordingly. But here you can see all the resource shapes that are registered and also all the objects that comply with all the shapes. So current Prolog OSLC SDK features are implemented are basically resource manipulation, resource handlers, default REST handlers, shape validation, serialization formats in XML, Turtle, and Triples, JSON LD, and basic OSLC client API through which you can actually send post requests from your applications. And also extensions to Cleopatra UI for exploration of the resources. And future features include resource paging, validation of value shapes, UI previews, and delegated UI dialogues. Right, so this is a list of useful links that you may want to explore. So the first link is pointing to the code base of the OSLC SDK and Prolog. It's on GitHub. It's under Ericsson Research Organization. The development environment is SWI, Prolog, and Cleopatra application server. So these are the pointers. SWI Prolog has a very active community, and the pointer to the community at discourse group is also there. If you want to know more about Prolog, I recommend to watch Michael Hendricks' introduction and production Prolog at Strange Loop in 2014, which was very inspiring. Markus Riske also created a book about Prolog, which is called The Power of Prolog, and there is an associated YouTube channel with all the explanations. And a couple of books by Van Bratko and Peter Flasch. They're kind of textbooks if you want to start learning Prolog and use Prolog in your daily life. And the last but not least is the link AI by Design, where you can learn more about how AI is applied in telecom domain by Ericsson and what are the practical applications of them. Thank you very much. I think I'm just in time.
Thank you, Leo. Thank you, everyone. So I think you have managed to convince quite a good amount of people. 67% of people consider Prolog a good addition to their tool belt. We have people reporting problems with the live stream. We're trying to change the bitrate to lower it a bit to see if it will become more stable as we do that. And if that will not help in a few minutes, then we can take up to 30, 40 people to the GoToMeeting. So let me know on Slack or on MutePS if the conditions improve or not. I'll clear the complaints, not because we're ignoring them, but just to see if you're still having them. And we did not have any questions to Leo. Maybe this is due to technical issues. Leo is on Slack, so if you'll rewatch this presentation afterwards, just feel free to join Slack and ask all questions to Leo. Okay. Can I ask you for a pulse? Use thumbs up if the stream is going well for you, or this confused face if it's not, before we proceed to our next presenter. And while people do that, Leo, we have one question for you. Can you give an example of use of OSLC at Ericsson?
Yes, so one of the usage was to actually manage a knowledge base of basically metadata about the radio base stations that are deployed country-wise. So we created a knowledge base with all the metadata, and then we used this OSLC library to actually provide kind of semantic search capabilities through which we could explore this knowledge base. This is very simple use case, but in the future we foresee that there will be more kind of involved handlers that not only do the query of the existing knowledge and search, but also will perform reasoning and inferencing, and also maybe executing external services according to the requests.
Thank you, Leo.
Thank you.
This was a very inspiring venture into cutting edge of using logic programming and linked data to build more intelligent systems in the future. And now our next speakers will actually jump to from the very low nitty-gritty technical levels of cool stuff to the very top level abstraction and discuss the strategic role of PLM capability and where OSLC fits into the picture. Åsa Nordling Larsson is a business analyst at Saab Aeronautics and works on business development and system engineering methodology. And Eric Herzog is a technical fellow at Saab. Åsa, Eric, the stage is yours.
Hi, thank you.
Thank you very much. So I think we can start. So we would like to talk not about perhaps something very abstract. So I would say something very practical, but very far from programming. So this is going to be about the role of OSLC in an organization or an enterprise PLM landscape. And also and myself, we have presented together many times, but this is the first time we're doing it from separate locations. So it might be a little bit interesting, but let's hope for the best. So we're working at Saab Aeronautics, and perhaps you can say that we are in the bird industry. So we are building birds like this one, and maybe a bird watcher like this one, the Saab Global Eye. And we're also building parts of the Boeing TX or T9 trainer. So aerospace is our domain. And we've been in this business for about 85 years.
So, looking at the PLM landscape of today, we got a very traditional landscape. We use Teamcenter, a very centralized PLM system in our business. It works from one perspective. We have plus when we look at cross-discipline collaboration, coordination between teams, big changes and so on, and also traceability. But if you look from an engineering perspective, well, it's not that good. So when we look forward and see that we have to change, we also look forward to see what we can do if we look at the IDEs, the integrated development environments, which is more discipline-specific environments. If we can use these and get more efficient from an engineering perspective instead. So that is what this is going to be about, to see what our new landscape is about.
And we can also see that in the PLM world, once upon a time, the PLM systems, they operated on a very coarse grain object. It was documents, and typically you had front-end applications interacting with the PLM system. But it was rather a long distance between the front-end application and the actual information management within the PLM system. And our current PLM system belongs very much to this generation. But when we're looking at the market today, we see a new breed of PLM systems which actually manage information at a very fine granularity. So it's no longer about documents, it is about the individual information items within the tool. So basically we're going from managing a requirements document to managing the individual requirements within PLM. And I will just talk a little bit on a specific thing that we'll cover later on, and that is a distinction that we clearly make internally in our organization between definitions of items and their realization. So typically when we look at a definition, we build our system structure top down. And for each node in the structure, we capture our requirements, the design, the verification procedures, and so on. And typically we build the structure, or would like to build a structure, so we can identify the nodes in a mechanical PLM system and capture requirements and design and verification there. And of course, we could also do it for individual electronics nodes or software nodes, and maybe do that in separate PLM systems. And as development progresses, we will see realizations emerging. So this is something, the yellow circles, something we build in accordance with the requirements with the design, and we can start verifying them, and hopefully they are compliant with our intention. And when we have well-functioning leaf items, hopefully we can create and integrate and create a realization of our system level node. And it is this combination, we have definition separated from the realization, which is very important, and we'll come to that in the next slide.
Yes, we started to look at the current landscape of today and see what we could do to make it better for tomorrow. So we started to look at what we have to be aware of when we are starting to look into what we have to provide the engineers with. And we have to think a lot about the requirements. We must think about the structures for configuration items, the changes, and the realization structures, as Eric talked about. And from an engineering perspective, we have different kind of engineering disciplines, and all different disciplines, they are delivering about the same thing. If you look at it on a very high level, like requirements, design, realization, verification, and declaration. It doesn't matter what kind of engineer you are doing about the same things, but on different levels and in different ways. So that's why we started to look at these traceability dimensions a little bit further. We believe there are 4 of them. We like to discuss that with you if you agree with us or not. So then we started to think about, if you are a systems engineer and you are doing requirement management, you usually use doors or something like that. But if you are a software engineer, you don't like doors so very much, even if today we force them to use doors, even if they don't like it. That means that they have to switch between programs a lot, because doors isn't where they are doing their code. So from an engineering perspective, that is very insufficient way of working. So what we have to think about is to trace between like requirements from different engineering perspectives. So if you're using doors for systems engineering and you're putting your requirements on the software nodes, the software team can use another methodology for their treatment of the requirements. Like they could write user stories or epics or something like that, but you have to trace up to your parent requirement from the system engineering view. So the traceability is very, very important to trace, and the requirements, they are traced from bottom up. That's the small arrows above the vertical lines. The configuration items, they are top down. Coming from the system view, you identify nodes below you. The changes are coming both ways, both when you are developing a big new functionality. The changes come from above, from top down, but you can also have problems coming from bottom up. And then you have the realization structure, which come bottom up, which you have to trace from a component to assembly and so on, even if you are in a kind of ALM system for the software. We hope that we could do this in more efficient development environment for different kinds of engineers. So we could trace between the objects instead of forcing them to use the same system or the same tool. Our products, they are alive for a very, very long time, at least 30 years. Some of them have even more years to go. We have our SK60, it's almost 60 years now. So we need to have some kind of archive, and that is also included in this landscape model for our future PLM strategy. We need to keep track of data for a very, very long time.
And the archive may be a very simple PLM solution operating on a document granularity, where
Could be that. Could be the coarse granularity level, which we were talking about as the old way of thinking about the PLM strategy.
So if we are focusing instead on not the vertical dimensions, making sure that everyone gets the same requirements management tool, and instead focusing on providing the engineers with integrated development environment, then we should, at least in theory, be in a position where we can allow engineers to automate their work within their engineering discipline. And they hopefully can keep within the same integrated environment most of the time, and would also provide us with an opportunity where we can have engineers and managers working in the same environment. So from a systems engineering perspective, that would mean we would do our local requirements management, manage the config structure, doing the change control, and keeping track of realizations within a single integrated environment. And the same would be true for the hardware engineers and the software engineers, as long as we can maintain these 4 traceability dimensions. So we can trace requirements, build up the config structure, do change control, and keep track of our realizations. And if we can keep this architecture, we should be in a position to do some relatively easy changes. So perhaps if we need to, we find out that our software engineering environment, it's no longer up to standards, we should be able to take it out and replace it with something similar, as long as we are conforming to the same interface definitions, and we still maintain the capability to link between the environments. And this is, of course, where OSLC appears to be very attractive to us. The ability to link without considering or without forcing homogeneous applications within the environment. So this way, we hope to be able to modify our PLM environment gradually without having to make big upsets and replace everything in a single go. Because we know from experience that such big replacement projects, they are horribly expensive.
So the traceability, that is the key of the PLM landscape model. So we need to ensure that we have traceability between all the environments. And that is to keep track of the integrity of the product data, even if it's not stored in the same database. We believe we are focused on the correct dimensions for traceability in the requirements, the configuration items, change management, and realization. And it's really a big matter for us to keep that, not in one database, but in the links between the environments. And of course, we should have versions and baseline capability that is a must for us to keep this up to date, and even for these many years for our products to live.
So this must be supported in the individual requirements, but also in the linking across the environments.
Exactly. So when we talked about this with all the teams, we started to discuss with them what kind of dependencies they can see today. And today the dependencies are very rough. It's not quite clear. The requirement management, that's good because everyone is using drawers, so the requirements is really good. But we have to do the mapping between them. If they want to do requirement management in another system, we really need to keep the dependency mapping up to date. And I mean, that is true also for all the other disciplines, like realization from software, realization up to a system level. We need to keep track of the dependencies and the interfaces.
So to summarize, we have presented a high-level enterprise PLM landscape model where OSLC appears to be the key enabler for realization. The status is that this is our intended architecture for future programs. We are still in our initial phases, but doing things this way will also have a substantial impact on our own internal organization. And since this is new for us, it's a new way of thinking, we are very happy and very open to discuss this with our industry partners. I mean, is this a good way to realize the future PLM landscape? What are the things we should think about? And also, how can we, along with other players, contribute and promote OSLC? Because Saab is very much new to OSLC, and we would very much like your guidance from you specialists. Thank you very much.
Thank you.
Thank you, Eric. Thank you, Åsa. We have 2 questions, but we are running short on time. So I'm going to do the same as I did for the last 2 days. I'll post them on Slack, and I would be very thankful if you could join Slack and answer those 2 questions. And everybody, please join Slack and let's continue the discussion there. Also, Eric, thank you again.
Yep, thank you very much.
And now we're moving on to another speaker from the aerospace domain. It is my pleasure to introduce Nicolas Figuet. Dr. Figuet is a system architect at Airbus, and today he will talk about strengths and weaknesses of OSLC when it comes to establishing a digital continuity. He has experience in strategic PLM governance and interoperability research, so it's going to be an interesting talk. A quick reminder, submit your questions on MeetPS. If we don't have time for them, I will copy them over to Slack, and I'll try to make sure that the presenters see them and answer them. Nicolas, you have controls.
Hello, everybody. Do you hear me? Hello, do you hear me? Okay, so good morning, everybody. So a quick introduction. So I'm an expert in the PLM area, and I've been working for years in establishing digital collaboration between different partners working in the same product. The product could be an aircraft, a satellite, or any kind of other manufactured product. And during these different years, I had to deal with the current challenge we have to face to, means establishing a digital continuity for end-to-end collaboration. So first, I would like to share with you what does it mean exactly in this context. So enterprises are relying more and more on computer and software systems, which will realize applications. Application will be used by organizational units, running processes for developing products, and they will be used for defining, enacting, running, or monitoring the products. So that could be manufactured ones, but also services, and will be also used for what concerns associated processes in order to support the different activities related to the product. So from organizational point of view and the structure we have to face to, first we have to consider that enterprises are part of a larger business ecosystem or several business ecosystems. The organizational units will have to collaborate within the enterprise with the other ones and following some private processes, but also between enterprises. And when you want to enact and support the collaboration between the enterprises, you can make it in several ways. First, it could be running enterprise processes, which will imply the external actors. So the process is defined and controlled by the enterprise. So it's what we can call extended enterprise, or it will be run with external cross-organizational processes, which are not under the control of the enterprise itself. It's defined externally, and the enterprise will just collaborate and participate to this process as the other. Is what we can call a networked organization. So establishing digital continuity in this context means that the data flows are continuously enacted between the software systems, which realize the applications and which are used by all the collaboration participants, all these participants being distributed in different organizations. So such data flows support communication of information for efficient decision making, and they also realize the tasks for assignment flow, the flow for task assignments, or the flows for digital artifacts that has to be shared between the different workers. And the digital artifacts would be documents, data, models, or a lot of different things. So what does it imply if we want to set up such a collaboration? If we want to achieve a sustainable full life cycle interoperability between the software systems which realize the application involved in the targeted collaboration. And this despite the continuous evolution of information and communication technologies. We will have some problems to deal with that because we will not be able to maintain the interoperability, the continuous one of the operations. So in the past work, the point was that if you want to create the environment to set up such interoperability and to support the digital continuity, you will need to rely on standards and open standards. And in this context, OSLC can be considered as one of the enablers for digital continuity for end-to-end collaboration. So the question here is, compared to the other technologies and standards, is OSLC suited, and can we respond to this question to use it and how to use it as an enabler? So in the past, and all what is presented here relies on the experience gained since several years with an approach which consisted in having several research projects, most of the time European, and you have the list here. And it was combined with activities on standardization bodies like ISO, and also communication with other organizations like OMG, OASIS, W3C, and some industrial governance standard bodies like SSG or internal instances. And it was also combined with the actual practices. It means operational projects related, for example, to the PLM harmonization within the Airbus group, or collaborations through PLM hubs like Boost Aerospace. And for all this, there were several iterations all along the years in order to make evolve the practices and the way to deal with all these problems and needs. And the different standards that have been assessed all along these years are some in the PLM and system engineering area, and they are, I will say, more business or domain standards. It could be application protocol like STEP. Some presenters already talked about the standards previously. It could be also some standards for distributed system like PDM enablers, PLM services. It could be also some technology or standards defined by OASIS like DexLib and PLCSLib. And you have also some standards providing, for example, a process framework like ISO 15288 or SCORE. So with all these standards, OSLC come, and for some people, like a way of standards that could support PLM, even if initially it was defined for application lifecycle management. And at the left side, you have a set of enabling technologies that are related to data exchange or to data sharing with, for example, middleware technology like Corba, web services, and so on. You have also standards for application or software design or for the capture of the needs, like ORM, for example. And in all this picture, you have also OSLC that rely on a set and a stack of technologies that are, I will say, more modern than the previous one, and that are the RESTful application, RDF. And relying on this technology, OSLC aims or propose to provide new modern way of interconnecting the different applications dedicated or to application lifecycle management or to product lifecycle management. So OSLC is one component, is one element, but it's not the only one. And when you are thinking in terms of end-to-end collaboration within a network of organization for PLM context, you will have to use several standards in combination, a consistent way, in order to respond to the whole needs of the enterprise and to cover them completely. And for this, you will need two things. The first thing will be to prepare the interoperability through governance. And here it's a question of willing of the different partners who want to work together. And the second approach will consist in building the operational interoperability or the environment to make it happen. In here, it is a question of architecture And the different architects involved in the process, so the people from infrastructure and software or computer technologies, plus those related to information system, plus those related to the business processes in order to fulfill the objective of the enterprise, will have to collaborate together in order to set up such a thing. So it is a reason why enterprise architecture could and should play an important role, and I put around 2 boxes, enterprise architecture 1, with the standard. Of course, it's always a question of open standard. Today, the one that is assessed and used is Archimedes. So, excuse me, for the governance of standards, one activity, it's the ASD Strategic Standardization Group. So ASD is a European organization with aeronautics, space and defense main actors. And an initiative was launched called the Strategic Standardization Groups, which aims to have all the people around the table and to monitor the different kind of standards that can contribute to set up the digital continuity. And for that, here one of the tools they are providing is the radar screen, where you have a track of the different standards. There are those available externally, those that are monitored. We monitor the external development, so we push some resources in order to make them developed. You have also some ESD standard development contributing to the big picture, and it's also possible for the member of the consortium to participate in external development for some standards. So it is, for example, AP242 that was pushed for this ecosystem through such an approach. And here you have OSLC, so you can see OSLC as an available external standards. And for each standard of the radar screen, you have a lot of documents that are very simple, that are reflecting again what is the status of the standards concerning the whole picture and the radar screen. And you have a little document explaining why the standard could be interesting. So an abstract, those are the stakeholders, what are the main principles. So it's 1 or 2 pages. And the idea is to have really a good idea in order to decide from a governance point of view where we will invest and what should be the consistent set of standards to use together in order to work and to collaborate a digital way. So all these documents are public, and I provided the links as in the reference of the presentation. Then you will have to think about architecture. So I will not make you your presentation of an Archimedes model to support it, but a simpler framework that is used at ASD SSG. It's close to what we can do with enterprise modeling. You have to distinguish business process and scenarios that are really things that are driving the needs for information exchange, application, and technology to be used. You have then the information, so you will have the scenarios and use case, and all what the things that have to be exchanged in the collaboration scenarios in terms of product definition, documents, and all what is related to processes. Then all this will be produced and consumed through applications that result from some technologies that are deployed, enacted, operated to make the application usable by the targeted actors of the processes. And finally, you have different family of technologies and infrastructure that could be compared, and you can have some patterns in order to deal with the different stack of technologies that are on the shelf in order to support the collaboration. So if you are working with STEP, for example, you are more for data exchange and sharing with what I will call traditional ways. Then there were a strong evolution from Corba to the web services with technology based on XML, SOAP, and this kind of things. Then you had an evolution from that in order to go to the RESTful architecture and with more lightweight technologies relying directly on HTTP and making, I will not say the other technology obsolete, but in some case less accurate in order to respond to some needs where the resources you need to run the services are less, the services are less, I would say, powerful. So I'm thinking about Internet of Things, or maybe some phones that can be smartphones that can be used in order to collaborate. And in this case, you need another family of technologies. And in this case, those OSLC is relying on are more accurate. Also, being based on RDF, the idea here is not anymore to make some data exchange between systems, but to publish a system and to be able to link them using the link data as defined by the W3C, and a set of family of technology stack that can support a way not anymore to give the control to data at the outside, but to be able to publish them, to aggregate and work on them, and then to change them back on the referential of data that are used in the, I will say, in the local information system. And other kind of technologies that can be related are all those that are related to visualization. So with such a framework, the idea is to be able to assess the different technologies and then to be able to give a flavor of the added value and the interest of integrating or not OSLC in the global strategy and as a component of the approach. So the response is not yet, I will say, definitive, and here it's not, I will say, a result of the work that have been done, but more of feedback. When I had to assess the technology, I faced some difficulties, and I had also some questions about the future of OSLC, as we need also to manage roadmaps and to have a vision of the future in order to anticipate the investment and to preserve them on the long term. And so I will share with you some of them. So let's consider it a positive way, identify some issues, and the idea is how to be able to go a step further in order to be able to easily integrate OSLC in this stack of technology that will be really relevant in order to set up such a strategy. So the first feedback is the following. Sometimes, looking at what was produced, there was sometimes a confusion between application lifecycle management and product lifecycle management. And sometimes some things are very similar, but it's very important concerning the process of enterprise to really consider that application lifecycle management and product lifecycle management are really two different processes, and what the concern and the people involved in the processes are different. So it's something that should be considered very cautiously, not to confuse ALM and PLM, because the skills that are required and the needs are very often different. The second point is about the vocabulary. There were some attempts to provide a simplified vocabulary and a set of concepts, very simple, compared to more complex application protocols. But sometimes one issue was the fact that some concepts were redefined separately, and there were some effort about liaison, especially with the STEP community. And the idea is we have to take care to align a little bit the concept and the vocabulary. It's not a full dependency, but the most the concepts are aligned, and the better it will be to use consistently the different standards as enablers. The third point is about the difficulties with OSLC roadmap and configuration management of the different components of the OSLC standard related documents. When you are navigating the different sites, so there were a move from the previous site maintained by IBM for the open OSLC community. Now, since I will say 1 or 2 years, you have a comeback to a new site in order to manage and to govern the evolution of OSLC. And when you look at the different documents, it's always very difficult for the different part of the standards to know which version is working with which one. So it means how are they interrelated? Are they all at the same status? And what is the impact? And then when you will have an application, how do you deal with the conformance and the qualification of the application compared to the standards? And when you don't have that, it's very, very difficult for people coming from the outside to be sure that you can manage properly the way you will combine them and have a strategy, because you are always to reassess the tools, and it's sometimes difficult to do. Another difficulties is I didn't catch, even if you have LIO or some other tools, a kind of implementation of reference for the specification with a better usage experience for deploying it and playing it without effort. So here I could give the example of Apache Pop, providing a server and a client in order to play with the specification, and that is very easy to deploy. And another point I identify is interoperability between OSLC 2 and OSLC 3, because we are targeting a continuous interoperability, so something sustainable and long term. And for that, it could be an issue, as today there's not so much request for OSLC 3. And however, it will be important for something open to have a progress on this part and to see how to go to how to prepare the future to make it more successful and more used. Another point is about the link with the W3C linked data standards with isograph querying language that will come also in order to propose a querying language for all the graph. So what are exactly the relationship? We have in one hand OSLC shape versus shackle, and we will have to deal with multiplication of shape definition languages and technology in the future. So here it's an open question. And also there will be RDF star and GQL coming. So what will be the impact on OSLC? For the fifth point, we deal with some limitation of RDF in terms of expressivity, because here you have a simple graph. RDF deals with individual, class, and relationship, but you don't have, I will say, more complex construct like the relations that you can find in UML, ORM, or EER. So, and for this case, it means that sometimes RDF is providing only flat models, and when you are dealing with complex system of system with multi-scale models, it can be an issue. So it's one open point also, how to deal with that. We have also architecture representation for OSLC architecture of reference. So today we have some pictures, but we don't have, like in some other standards, a kind of clear architectural representation that help architects like me to really assess and to identify the different pieces of the architecture. And finally, Living Lab for testing and assessing specification and implementation could be very easy. So those Living Labs exist that could be shared by the community in order to help to progress in the definition, implementation, and usage of OSLC. So here it's just a little timelines that I produce in order to highlight all the evolution of standards I was talking about. And you can here retrieve OSLC v3, but also the start, the other standard from W3C, and some standards from ISO that could be related to PLM or ALM. It's, as you can see, something that started a long time ago and that will progress again and evolve. So we need, in terms of governance, to be able to deal with that. So it's the end of my speech. So here you have some references on some articles on ASD/SSG and all things talking about these topics. And you will have some backup slides that maybe can help you to see what was the work done previously and to have maybe some ideas or questions if you have some. Thank you for your attention.
Thank you, Nicolas. I think it's a great and shall I say, a bit thought-provoking presentation. I think there will be a lot of discussion about it. We don't have time for this now. We're running behind schedule, and I'll hand off shortly to Mike. But once you'll send us the slides, I'll try to open a thread on OSLC forum. And I think we'll have a very long and hopefully productive discussion about this. Thank you again, Nicolas, for presenting.
So my pleasure, and thanks for inviting me.
Our next speaker is Mike Amundsen. and he needs little introduction. Mike is a renowned API expert, author of 6 books, at least that's how many I counted, and many presentations on the subject. Today, he'll make another pitch for Hypermedia, this time in a show and tell format. Without further ado, welcome, Mike.
Hello, thank you. Can you hear me? Can you hear me?
Loud and clear.
Okay, excellent, very good. It's great to be here. It's great to join you today, even though I'm far away in Kentucky. I'm thinking about you very much. So let's, since we have just a short bit of time, let's just go right into what I wanted to talk about. And I'm just going to flip over here and start my slides. So, okay. And I assume everyone can see my slides, yes?
Yep.
Okay, very good. So what I wanted to talk about, so when I came to the OSLC event 2 years ago, I talked about this idea of hypermedia and tried to talk about the sort of the basic elements of why hypermedia can be valuable and can be important in establishing networks of computers that talk to each other, even when humans are not around. So this time I thought that talk was very sort of conceptual and somewhat theoretical. I thought this one I would actually show an example of what I wanted to talk about and what the kinds of projects that I work on. So this is me. This is how you find me on LinkedIn and GitHub and YouTube and Twitter. And it's about the only way you can find me now. I used to travel quite a bit. Now I travel only virtually here from my back room in my house. I'm just finishing up a book on designing and building web APIs for pragmatic publishers. Some of the material that I'm talking about appears in that book. However, most of what I'm showing you today is from a book I wrote just a few years ago called RESTful Web Clients. And it's really about the idea of writing machine clients or clients that understand how to parse hypermedia formats. And that's really what I wanted to show you today. So I wanted to talk a little bit about the goals of why write hypermedia formats, why create hypermedia servers and apps, what are we really trying to do? And then take a sort of a view of a particular implementation using a format I created called collection.json several years ago, a sort of a view as a consumer of the API and a view as a provider of the API. What's expected of me? What do I learn? What do I discover along the way? So from the sort of goals perspective, really, I wanted to focus on 3 key reasons that hypermedia can be valuable. It can improve the reach of your application. It can increase the usability of your service. And the most important one is it can reduce the amount of code necessary to interact with you. If we take a look at why HTML and HTTP is so effective, it's really because there's a very low barrier of entry. I don't have to know a lot. I don't have to know a lot about the protocol. I don't even have to know a lot about the format. I don't even have to write a client. There's already a client for me. So there's an incredibly low barrier of entry. And it has a super high utility. In other words, I can put together a server relatively easy, or I can put together a page on a server, or a folder, or a set of pages. I can link to things that I've never heard of or people have never seen before. I can make connections without having to have a meeting, without having to have an architectural session. There's a lot of things I can do very early in the process, and that's a very important goal for hypermedia in general. It's also important to talk about how usable hypermedia has been, HTML and HTTP in particular. A big part of this is that HTML, the format, is not about content at all. It's about documents. It is a highly structured format. It isn't just an XML or angle bracket format. It's an XML format with structured names like title and head and body and script and link and form. These are highly structured elements. So it has its own semantics, it has its own syntax, but its syntax has nothing to do with objects. It knows nothing about users. It knows nothing about products or services or documents or even images. It just knows about content. And that's a really important element to think about when you're designing and interacting with hypermedia. Hypermedia design is not about the content. It's about communication. I used to, when I taught hypermedia format writing, I said, you're creating a language. That's why these were originally called hypertext markup language. You're creating a language with which other people will discuss whatever topic they're interested, not what topic you are interested in. So a good hypermedia design allows people to communicate with each other in a format that's meaningful. And there's another big rule in hypermedia formats that is really critical, and that is whatever is not in the message has to be written in the code. If I don't explain to people how to use a URL in the message itself at runtime, then I've got to explain it somewhere else, like in documentation. And if I explain it in documentation, it's going to have to be written in code. So however much I can actually get into the message, that can be taken out of the code. And it turns out that messages are much more easily shared than source code. Source code has all sorts of dependencies on location and time and format and operating system and platform. Messages do not. So the more I can put in the message, the more reach and the more usability I can get while I reduce the amount of code. And if I can reduce code, then I can last much longer. Changes that I can make without changing code are incredibly powerful. So having said that, those goals of reach, usability, and reducing code, let's just take a consumer view of what a hypermedia format and a hypermedia client looks like. So I'm going to pick one format. There are a handful of formats in the last 10 years that have gotten pretty good at this. HAL is a very popular hypertext application language. Collection JSON, the one I'll show you here, Siren, Uber, Mason, even OData has some power to it in this hypermedia regard. So I'm just going to pick one. I'm going to pick one that I'm familiar with and that I have an easy client for. So we're going to take a quick tour of this collection JSON format, and we'll talk about what a structured format looks like. I'm going to show you an SPA client that I built. I just built an SPA client because they're easy to build, not because it's a requirement of collection JSON. And then we'll just take a little bit look at the code. So this is actually the app that I'll be showing you. I'll be showing you running on my local machine, but there's a link in the slides to this final this live version as well. So we'll take a look at this app and we'll see what's in the code, what's in the message, and how those two relate. So let's take a look at the message format. The message format for collection JSON is basically, collection JSON was designed to mimic a lot of CRUD operations, but to do it in a hypermedia way. So the collection JSON, as I mentioned, is a highly structured format. It's got title, it's got a content block, it's got page level linking. So links are objects that have hrefs, rels, prompts. It also has a collection of items. So every item has its own rel and its own href and its own set of data and prompts and whether or not it should be displayed. Also has a separate section for queries. So these are just queries, filters of various types, and explains how those queries work. And it assumes that queries always use get. And then it has a template section, which describes an object that this particular page or this particular app is about. So creating, updating, and deleting are all done through templates. And the templates, as I mentioned, follow the CRUD pattern. This was designed to actually make it easier for people who work on the create, read, update, delete, post, get, put, and delete, to actually move easily. There's also an error object, but we won't talk about those today. So I'm going to show you the app. This is the entire markup for this SPA app. So what I did is I wrote a human-facing app for this format. And you'll see that it is all about structure. Here's where the title goes, here's where the content goes. If there's an error, it goes here, and then there are a couple of columns for items, and then for editing, templates, and queries. That's it. You'll see at the bottom of the page a reference to a library, the CJ client library, and some helper files, and the launch, the single URL that you use to start the system. And that's all there is. That's all you need for this application. I need to be able to know I'm pointing in a direction, pointing to a place. I'm pointing to a local place here in this particular test app. But that's it. The rest of it is going to be taken care of by the message itself. And this is what the client library actually looks like. I'll give you another larger view, closer view in just a second. It knows it's dealing with a particular structured format called collection JSON. It's looking for a starting URL. And once it gets a message that you can see that request with the URL do a get, it then parses the message and displays it for the human. So you can see since it's a structured type, it's very easy to write. Title, content, links, items, queries, template, error, go. And the rest of the application here, the rest of the JavaScript here is really just solving those particular problems. By the way, the entire client-side script for this is about 400 lines. So that's about 400 lines for a structured format. And that will handle any topic, any content, whether it's about products or services or people or users or places or anything. it's going to handle that just fine. So I'm going to go ahead and just skip ahead here really quickly here. First of all, let's see if we can find the app. Oops, let's see if I can find the app. There we go. There's my app. So here's my app. I can interact with it. I can do edits if I want to. My mouse is a little poor here. I can simply do queries. I can move around in any part of the app that's interesting to me. Right? I can do even mark particular records if I want to, mark something as completed or incomplete, for example. So that's the input is very simple. So let's take a look at some of the code here. I'm going to go to the client side. So I showed you before, this is the entire application. There's a little bit of reference to semantic styling, and then there's the body of the application. And that's all there is to it. There's a very small script at the end that just gives the initial start. So it doesn't take a lot to ship this around. As a matter of fact, I have a version of it that actually writes that initial HTML in the beginning. So all you really need is a div link to begin. This is the engine I use. There are actually several extensions in CJ. This talks about which ones they're using. But this goes to this space that I talked to you about earlier. This is actually the structured elements. If I go down to the very bottom, there's really nothing magical here. There are no even client-side dependencies. This is just a simple AJAX request and response and parse. So I make a request, then I parse the CJ every time. That's really all there is to it. So it's almost boring. It's almost dull to know that what I have is a format engine that will accept, now can be pointed to any server that talks collection JSON. So if it talks to collection JSON, this client will work with it and be successful. All you need is a valid collection JSON message to pull that off. So let's get out of here and then go back, because we have just a little bit more time left that I want to show you the server side. So a highly structured message type, that's a key to writing good formats, and a simple client. There's less than 100 lines of HTML, less than 400 lines of JavaScript. It can easily be restyled in lots of different ways. And it's easy to add support for extensions for the code as well, because there's actually a set of extension rules inside the format. So what about the providers? What's in this for the providers? I can see what's in it for client applications. I now can connect to all sorts of providers. Well, I'll give you just a quick tour of the server. The servers are super simple. There's nothing special here again. Notice that this server actually knows how to write several hypermedia formats in response. So it knows how to do HTML, simple JSON, HAL, Siren, collection, and that WSTL is an internal representation of state transitions. It knows simple rules about routing. So I match actions to routes. Uses a typical pattern that I've talked about in books before. So there's nothing really magical here as well. What is interesting, or what may be sort of new to some in writing clients, is that it uses a pattern called the representer. So if you look on the left, you'll see that it checks the MIME type that has been passed by the client and makes a decision about how it's going to render the message. Will it use JSON, HAL, Siren, or collection, right? Or default, whatever the default is. And I think the default in this one is actually just plain JSON. So what I do is I can sniff for accept headers, and then I can actually translate that object or represent that object in a format. So that's the middle frame. So you can see the CJ representer there. And again, because it's structured, title, content, links, items, queries, templates. The related section is for dropdowns and suggest lists. In case there are errors, this is really the top level. And again, it gets boring after that. Take the object I'm supposed to render, get the title out of it, get the content, so on and so forth. And often the right pane, you can actually see what I briefly mentioned earlier, state transition languages. So state transition language explains how you can transfer from one state to a next. How do I edit a post? How do I offer up the form for removal, and so on and so forth. So this is a generic language that then can be translated into these other formats. That's probably the sort of the magical part to all this. And all of this is based on this thing I refer to as the DART model, which is data, actions, resources, representers, and transitions. And the data and actions are internal. and the resources, representers, and transitions are external. Most people focus only on resources, and they skip making transitions and representers separate. Extensibility is easy. I can simply add a new link to a new object set, like tasks or users or notes or anything like that, and then I can write my own actions for any of the details. So it's really, again, not very exciting. I can write an object to handle tasks, and then I can reference it in my application. It will then magically appear in all the apps. I don't have to rewrite the apps to do that. So relying on the representer, a very common internal model, a negotiated external format. So I want this message in application JSON. I want that message in HAL. I want another message in Siren. Using this data action resource representation transition pattern clearly makes decoupling easier. So data and actions are internal. My data model is not my my resource model, is not my format model. All these things we keep separate, but I can write resource representers and I can author transitions easily using this pattern. So now I'm decoupled and extensible. It's easy to add support for new objects internally or even new messages externally. If someone decides to come up with a new message format, we can do that as well. So let me go ahead and show you a little bit of what that looks like as well. Oh, apologies here. So the top level application, we saw this earlier, simply listens for routes, and based on your routes, it handles the messages accordingly. So if they call a route for tasks, if they call it for home, if they call it for users, if they call it for notes, it just passes all of that off. And if I add a new connector, and that connector, by the way, doesn't even need to be local. The connector can be remote. If I know there's another service that responds in collection JSON format, I can simply add it into my app, just like I would add a link inside HTML. And suddenly I have a connector to that other application. And in this case, in an SPA, I can actually render that application inside my own pages. So let's just do a couple of things here. So I'm going to go back to my app. So you'll notice here that I have this idea of the standard CRUD operations plus any custom operations. What I want to do is I want to add a new operation for every item in the list. And actually, it's a transition to assign this. You see, we have an assigned user, to assign this task to a user. So all I need to do inside my application is go to this transition language file. And let's see if I can find what I'm looking for. There's a series of transitions that I describe inside the app. I apologize for running so quickly here. I want to make sure I get to this before we're done today. And where are we? Here we go. We're getting to the changes. Remove. And here we go. Add an assignment. So this is the transition that allows people to add assignments. It explains a few things, and there's a little bit of extra markup. So I'm literally going to add this back into the code. And now when I refresh the app, I can now assign a user. I didn't have to write anything. I didn't have to change anything. But now that assignment is available to me. There we go. Having trouble with my mouse, I apologize. So now that form has been described. It actually looks up from another source to find all the information it needs. That's all described in the form, and this application just simply renders what it's given. Now, the other thing that I talked about earlier is connecting to a whole nother class or a whole nother set of services or a whole nother object. I've got another opportunity to do that as well. So let me go back up here and find the profile for starters. Here we go. And there's an opportunity to actually connect to a different service to support notes as part of the app. And same thing happens. When I render it now, I actually get a whole notes service as well. And this can be delivered from my service, or it can be delivered from another service. So the advantages of these applications are they work on structured formats. They're designed to read the message, not the content, and let the human deal with the content. So I'm running short, so I want to finish up. So just to talk quickly, This allows us to extend the reach of our apps because we're adopting these structured messages. It means we can reduce the amount of code in a message. Adding objects doesn't increase the amount of code. Adding actions doesn't increase the amount of code in a client application. Changing the arguments, changing the variables, changing the URLs, changing the links does not adversely affect or break the client in any way. Clients can be bound to messages, not content. That means they can be extended in ways that are based on the message model. If I want to add new regular expressions or a new way to connect or a new way to render an object or a frame or so on and so forth, I simply need to update the message format and then update clients as time goes on. And then finally, I can focus on a decoupled model for the server by focusing on data and actions internally and then keeping my external elements separate, not just resources, but also deciding which formats I want to render and actually describing transitions in a way that makes them a powerful first-class element in the server side. So whether you're working, no matter what kind of architectural model you're working on, no matter what kind of formats internally, data formats you're using, you can use these hypermedia formats as client applications. Now, here's the challenge. We need more structured models, more structured message models. I mentioned a half a dozen in the last 10 years, but that's not enough. We need more experimentation. We need more generic clients that work not just, not changing code, but just changing messages. So I've written some generic clients for some of the key formats, Siren and Uber and HAL and collection JSON, but we need many more. And we need better clients, clients that run on all sorts of platforms, clients that are focused for particular needs and uses. We need to do negotiated vocabularies when we get into machine space. So you already have lots of good vocabulary experience, but we need to make vocabularies negotiated the way we make messages negotiated. I want to speak to you in version 5 of the FASB accounting system, not version 4. So a server should be able to negotiate for a vocabulary. I and a few others, Leonard Richardson, have come up with a format called ALPS, Application Level Profile Semantics, to do this work. It's been around for several years and it's used by some developer tools, the Cloud Foundry tools. And then eventually we need runtime discovery. I need to actually have DNS for services, not DNS for servers. So I need to be able to find at runtime, is there somebody who handles FASB accounting version 5 for me that I can connect to right now? Is there somebody that handles shopping? Is there somebody that handles credit cards? And do that in real time. And this will raise the bar. This means getting less and less code out of the system, more and more messaging in the world, more structured messages, more generic clients, negotiating what we're talking about with the vocabulary, and negotiating how we find things with runtime discovery. And that's really what I have. I tried to get through that as quickly as I can without skipping over important things. Hopefully that you'll find that helpful. If you're interested in the book I have coming up, this is a link. There's a link for the RESTful web clients where this particular client comes from. And I'll be posting my slides at this URL, and I'll share this URL in the Slack channel. So you'll be able to get all the slides and a pointer to a live version of the app as well. So that's it. I just wanted to say thank you very much. And hopefully this sparks some interest and some ideas. And I would love to talk more with you at some other time. Thanks a lot.
Absolutely. Thank you so much, Mike. An excellent example of a Hypermedia API, not so scary, and we're eagerly awaiting for your book. Everyone else, please join Slack and ask Mike for the questions there as we're running short on time. Again, thank you, Mike.
Take care. Bye-bye.
Our next speaker will talk about OSLC-based integration of Capella and IBM JAS. The speaker is Ahmed El Berdi, who is currently an MBSc practice engineer at SI France. Ahmed, the floor is yours.
Hello. Yes, Andrew. Do you see my screen?
We can hear you well. We can see your screen.
Okay. Do you see the first slide of the presentation, please?
No, it's just a wallpaper.
Okay.
No, perfect.
How about now? Okay.
It disappeared for me, but now it's there. Yes, perfect. Go ahead.
Okay. So hello everyone. For this talk, we are going to see a kind of simple way to how integrate a Capella modeler to IBM Jazz using OSLC. And before that, I will start with a brief introduction about me. Ahmed Elberdi, freshly graduated engineer. I have been working for SDKs for about 6 months now as a MBSc practice engineer. Before that, I was able to join Safran Landing System for a year's internship. And among the missions that they have assigned me was to look for a way to make traceability realizable between Capella model elements and those next generation requirements in a multi-configuration context. So thank God the OSLC exists. So before moving on to explain this type of integration, for those of you who don't know Jazz, I got this. I personally believe in the power of the model and the ease with which the human mind can interpret it. So what we can see here is a UML meta model of a small parts of the Jazz platform architecture. Focusing on requirements management domain, application, doors next generation, and the global configuration domain. So as we see here is Jazz team server as well as requirements management application and global configuration management application are linked together by OSLC. Here get also such so the configuration management offers capabilities to create versions of artifacts and link them to other team artifacts such as requirements and designs. Streams and baselines are used to manage reuse, traceability, and parallel developments. And for the global configuration management application, it's used to assemble configurations into global configuration to provide a context for resolving links between this time between version artifacts within a cross Jazz platform application. So the global configuration assembles all the relevant artifacts like requirement, designs, tests, source code, and other global configurations for a specific component's release or product version. What here is an example that I implemented on Jazz this way. So in the middle, I took as example a system called X and its subsystems in its subsystem level taxonomy. Sorry. So we have two subsystems. One is A and the other is B. And having a two version product, 1.0 and 2.0 version. The only difference between the two versions is that A, we have a system B 1.0 and for the system X 2.0 version, I get a subsystem B 2.0 version. So the system level global configurations are, as you see, holding local configurations of the from the ARAM application and global configuration of the subsystem, as we see in the pictures left and right. So to realize this type of integration, so there's two ways to make this possible using OSLC. The first was the possibility to develop a full OSLC adapter for Capella to make a Capella service provider so that you can be able to link it to Jazz. And the second way that I found interesting is that to develop a client type OSLC connector, the idea behind it is to allocate a project area on the IBM DNG with a specific customer template that will be holding different concepts of the Capella tool. This project will be dedicated and used to hold artifacts or model elements coming from Capella, so we can be able to trace them to the artifacts from the Jazz domain. So here we see in the picture like the Capella with the plugin GCC come to interferate as a middleware between with Jazz. And in these streams, as we see, we have a global stream or a global configuration for the System X for the version 1.0 that's holding local stream levels from project area for requirements and user needs, and a stream from a dedicated project area for the Capella artifacts. So it's demo time. So I'm gonna switch to my VMs. Andrew, can you please confirm to me if you see or you have visual of Jazz here?
For now, I see your demo slide, demo time slide.
Okay.
And now I see your virtual machine, I think.
Okay. Okay. So I got here in a project, a global configuration project called System
Now your
X, a
video
component.
disappeared. And now it's back again.
Okay, sorry for that. So as I said, I have in a global configuration project called System X, a component or a global component called System X that's holding two versions of this system. So the 1.0 and the 2.0. So if we have a quick look to the global configuration of the global stream 1.0 and 2.0. So we got here the version 2.0 that's holding the subsystem B 2.0 with the different streams or local streams, and the one dedicated for Capella artifacts. So what I'm going to do is I'm going to switch to Capella to try and using the Jazz Capella connector plugin to realize traceability between a model element from a Capella project to a requirement in the user needs. So a quick look to check whether if there's already a traceability links created or not. So I here in my user needs project a tree artifacts are not yet linked. As we see here, and here is a dedicated project area for Capella under the configuration 1.0. So as I see here, I got already a logical system. So I'm gonna delete that artifacts. Okay, make sure there's nothing. So here's on Capella. So here is the plugin. So we can try to connect to the Jazz by choosing an already created profile dedicated for this project. So it's handling the authentication with Jazz 2. So I'm trying to use my password. Sorry for the performance, but I'm running multiple virtual machines simultaneously. It will turn green once it is connected to Jazz. And after that, I will use a delegated UE to choose the global configuration that I'm gonna use, or I will create my traceability links under it. So to choose the global configuration, I'm calling the delegated UE from Jazz this way. So I will be choosing the system X 1.0. So here is 2 icons of those next generation, as we can see, that with a small logo that refers to AM for architecture management. So we can say that it's a project area that's dedicated for projects in Capella artifacts, and the other one for choosing the project area that we're gonna target for traceability. So I'm choosing the subsystem B Capella artifacts. So, okay. A user needs project area that's targeted. So I will create a logical function allocated to this logical system, for an example. What I'm trying to do is to link it to a artifact from the user needs. To do that, I will right-click on the logical function, go to Jazz Capella connector, and try to add a link. The delegated UE for picking requirements pops up. So I'm on user needs, requirements. I will be choosing the need tree. Hitting OK. So as you see, here is my artifacts created in the dedicated project area for Capella artifacts and linked to the need tree under the X 1.0. So if I'm navigating to this need tree, it will be under the configuration 1.0. And for the 2.0, if I check, normally I shouldn't have an artifact, so it's okay. So what I'm trying to do next is to target the 2.0 stream. So for that, I'm shutting down this VM, and I will try another VM. So here I'm already connected. To the Jazz server. So I will start by choosing a global configuration. And this time it will be the 2.0 version. I click OK. Go to the project area. Select it. Okay, I don't know if I have time to reboot this, but I'm having a problem.
Well, it's a usual thing, demo effect.
Yes.
One question that our attendees have is whether any part of this will be open sourced.
So it was, we already speaked about that with my ex-colleagues from Safran, and we are attempting to put that open sourced. Yes.
Fantastic. All right. If you will do the demo again sometime later, we'll be very glad to post a link to a YouTube recording on all our social channels. And thank you for this practical example of how you could use OSLC.
Thanks, Andrew. Thank you, everyone.
Our next speaker is Ruben Thalmann. Ruben is a postdoc at Ghent University and is passionate about linked data. Some things he worked on include trivial pattern fragments, Communica, and GraphQL LD. Today he will talk about the technical side of Solid. Solid is an important community for SLC, as we both share a passion for interlinked read-write web and use many common technologies, such as RDF and LDP. Ruben, the stage is yours.
Yes, thank you, Andrew. Can you see my slides?
Yes.
Okay, great. So in this presentation, I will be giving a very brief technical overview of the Solid ecosystem. So in case you don't know yet, Solid is a web-based ecosystem for decentralization. So basically, the idea behind Solid is that it decouples data from application, and it does this by giving everyone a personal data pod. And this data pod is in full control of each user. So the way Solid accomplishes this is by basically just being a collection of open web standards. So you should not see Solid as a tool or an application, but it's really just a collection of open web standards that can be implemented in any way you want. So there are a couple of standards that are important for Solid. In this presentation, I will be talking about 4 of the most important ones. So first of all, there's linked data platform that is used for reading and writing to and from Solid data pods. And next, there is the WebID OpenID Connect protocol that is used for authentication within Solid. On top of that, authorization is enabled through the web access control specification. And then the final spec I want to talk about is linked data notifications, which enables sending notifications between different data pods. All right, so linked data platform, you may already know that. basically enables reading and writing over HTTP. So the idea is that every solid data pod implements the LDP spec, or at least parts of it. And every pod can store any kind of file. This can be both RDF files and non-RDF files. If you are using RDF files, you get some more buffers, but you can also just store non-RDF files. So within LDP, you can make use of the typical HTTP methods such as get, put, post, patch, delete, and so on. And these methods, or at least get, supports content negotiation. So if you, for example, have a JSON-LD file stored in your data pod, you can also just request this in Turtle, and the solid pod server will automatically transform these formats. One important thing that is specific to RDF files is the HTTP patch method. Within Solid, this makes use of Sparkle update queries. So this is one example where RDF files have some more, or offer some more advantages over non-RDF files. One final thing I want to mention about LDP is the basic container functionality. So within Solid, this is used to offer a linked database directory discovery method, where basically every directory within your Solid pod can automatically be discovered, and the contents can be listed by any linked data enabled client. So those were that was a brief overview of LDP within Solid. So of course, next to storing files within Solid pods, another very important part within Solid is identity. So not only are people in full control over their own data, but also they are in full control over their own identity. And Solid makes use of the WebID OpenID Connect protocol for this. So in case you haven't noticed yet, all of these thingies here are just links that you can click on. So this refers to the full specification. So WebID OIDC makes use of web IDs, which is basically just a dereferenceable RDF web resource identified by URI, of course. So this link here is an example of a web ID. So if you dereference this, you can get some basic information such as my name, my image, and so on. And using the OpenID Connect protocol, you can make use of an identity provider to authenticate yourself or your web ID to applications. But I'll give a brief example of how this can happen. So let's say you are making use of a Solid application and you want to log into this application. The first step will be to select a identity provider. This is important because Solid, of course, is decentralized, so there is not one central identity provider. Anyone can set up their own identity provider, or you can choose to make use of a community-based identity provider. For example, Solid Community and Interrupt.net are examples of identity providers where you can decide to host your web ID. So let's say my identity provider is Solid.community. So I select this as first step in the authentication process. So when I click Go, I will be redirected to the Solid.community identity provider. And there I can then log in based on the authentication method that the identity provider has configured. In this case, Solid.community just makes use of username and password combination. So if everything is successful, you will be authenticated and the identity provider will authenticate you to the application. So then the application can do things like reading your files as long as you are logged in. All right, so that was authentication. So typically after authentication, you get authorization. So within Solid, you can give fine-grained access control to data using the Web Access Control spec, or WAC. So within Web Access Control, the idea is that every file within a Solid pod has a corresponding, or can have a corresponding access control list file, or ACL file. So this ACL file basically just describes who can access what resource and under what modes of access. So within Web Access Control, there are 4 modes of access. There is read, write, append, and control. Read and write should be obvious what these mean. Append is just a special form of write that excludes deletions, and control is a special mode that allows people to access this ACL file and edit it as well. But let me show you a quick example. So let's say Alice has a file.1 in her data pod, and she wants to create a Web Access Control file, or ACL file. So these are some example contents of what this ACL file could look like. So what is happening here is that you create a new authorization for Alice, so referred to the web ID, and this gives access to this file1 of Alice. And here we say that we give Alice read, write, and control rights. So note that this excludes append, because append is actually a small part of write. So of course you can add more authorization rules in this file. Like for example, you could give Bob just read access to this file, or someone else just write access, and so on. There are also special forms of agents. For example, the everyone agent, which basically is a wildcard that, for example, allows you to offer read access to everyone. Because by default, files within a solid pod will not be accessible to anyone except for the owner of this file. All right, so that was Web Access Control. Then the last major spec I want to discuss is linked data notifications. So what is this? So this is a spec that allows agents to send notifications between data pods. So a sender can basically send a notification to the inbox of a consumer. In essence, this is a very simple spec that looks like the email protocol a bit, but is then based on linked data. So some example where LDN is useful is, for example, well, there exists this Solid application that implements a chess game. So this allows people to play chess with each other in a decentralized manner. And using the LDN spec, different notifications are sent between the data pods of the people that are playing the chess game that contain the moves they make. So that's just basically one way of exchanging events between data pods. All right, so I just mentioned the 4 main specs that are used within Solid. Of course, there are many other standards that are used in Solid, such as WebSockets, for example, which offers an API for offering real-time notifications when a resource changes. WebID TLS is also a relevant one to mention. This is basically an alternative to the WebID OpenID Connect authentication protocol, but instead of OpenID Connect, this makes use of TLS certificates. But due to some browser issues, this spec is not used that often anymore. All right, so those were all the relevant standards. I just want to have one last slide to give a brief overview of the main tools that implement these specifications. So the most important one to mention is the Node Solid server. which is a reference implementation of a solid server that implements all of the relevant server-side specs, such as LDP, WebID, OIDC, or at least the server-side part, web access control, and so on. So the server is written in JavaScript, runs on Node.js, and is fully file-based. So any files that you create using LDP will be stored on the file system as just regular files in directories. So next to the Node Solid server, you also have the Solid authentication client. This is just a reusable library that Solid applications can make use of when they want to allow people to log into their application. So this is just a tiny library that implements the client-side part of the OpenID Connect specification. Then I also want to mention the Solid React SDK. This is just a collection of reusable components for when you want to create a Solid application in React. So this contains some useful components like a login form, an uploading form, and so on. And it also contains a useful application generator for just creating a very basic application with all of the required dependencies and configurations. And then based on this starting code, you can just write the rest of the application as you wish. All right. So the easiest way to get started with Solid is using the interrupt.net service. So this is just basically a public instance of a Node Solid server. And this allows you to create your own data pod and WebID for free. Note that this service has a limit of 25 megabytes in total per pod. So it's really, yeah, you really should only use it to do some testing. If you really want to store lots of files in Solid, then it's probably easier to set up your own data pod. All right. So those were the most important things I wanted to mention, but let me briefly summarize the most important part of this presentation. So the idea of Solid is to re-decentralize the web, and it does this by decoupling data from application. You should not see Solid as a tool or an application, but instead it should be seen as an ecosystem that is, yeah, basically a collection of open web standards such as LDP, WebID, OIDC, web access control, and so on. And there are a bunch of applications and libraries that implement these standards, such as the Node Solid server, the React SDK, and so on. All right, so this concludes my presentation. Andrew, are there any questions?
Thank you, Ruben. There are 3 questions, but we're running really short on time, so I'll move them to Slack.
Great.
Thank you again for your presentation. Solid community, as I said in the intro, is very important for OSLC and kind of makes us feel happy that we're not completely lost in our choices, directions in terms of technology. But also I think Solid is a bit more, newer and more bold and fresh than OSLC, and we're looking at some technologies such as LDN and WebID to refresh our stack. So
Yes.
Thank you for this presentation, and I hope we'll be able to connect on Slack.
Of course. See you there. Thank you.
Thank you. So now we are switching to presentation from Tarek Blahi from Persistent. Okay. This may be a challenge. Do we have Robert? Okay, so we're having a small delay. We don't have yet Tarek or Robert online. We'll try to contact them. Ruben, if you have not disconnected yet, how about taking the questions?
Yes, sure. I'm staying here.
So we have 3 questions, and the first one was when to choose linked identifications and when to prefer plain WebSockets.
Yeah, that's a good question. I don't think there's a good answer to that. The chess application I mentioned during the presentation actually makes use of both. So you can, when you start this chess application, you can choose whether or not to use the WebSockets based implementation or the linked data notification based implementation. So I think the main advantage of WebSockets is that there will be a bit less delay because your round trip times will be lower, since the server can immediately push things to your clients. But yeah, in case your application does not require that kind of, or it does not matter when there is a larger delay, which is probably the case in a chess application, then I think linked data notifications works just as well.
Okay, thank you. Moving to the next question. Can SAML be used in place of WebID in enterprise settings?
I'm not that familiar with SAML, but the thing is, Solid is not that dependent on OpenID Connect. Like I also mentioned that that the TLS-based authentication method can be used. So yeah, as long as you have some form of authenticating yourself using a WebID, the protocol you use underneath should not matter that much, as long as, of course, the server and the clients support this.
Okay. And can WebID or Solid be used in M2M scenarios where user interaction is not possible to authenticate?
That's a good question. That's actually something that is being looked into. I'm not part of that discussion myself, but I think, yeah, there are some discussions going on how to make that possible. So they are looking into to application secrets and so on, to as some possible ways to make this possible. But yeah, I don't know the details about that. But in any case, I can mention that all of the discussions, so how to specify solids further, are happening publicly on GitHub. So if you go to github.com/solid, there you will find some repositories. So all of the panel or repositories ending in panel are basically just discussion forums. So there they discuss relevant things like this topic is, for example, one of the things that is being discussed there. I suspect there is an issue, but I cannot find it at the moment. But yeah, if you have a look at GitHub, you will most likely find an issue about this topic.
Fantastic. We'll try to reach out and establish some bridge to the Solid community.
Great, that's perfect.
Okay, thanks a lot. We have our next speaker ready to present. We're going to make a small change. We have an extra presentation today from Robert Hellebrand, Robert is a field application engineer at Pure Systems. And in his presentation, he will announce OSLC support in their newest Pure variants, release 5.0. And if Tarek from Persistent is online, we will close the event with his presentation. Robert, the stage is yours.
Okay, thank you very much. So welcome everyone. For those of you who do not know the variant management tool Pure Variants yet, I want to start today with a quick introduction of it and then spend the remaining time going through all the OSLC related capabilities that we added to Pure Variants in our latest release, Pure Variants 5.0. So Pure Variants provides a systematic reuse approach based on feature modeling and the use of superset engineering assets. The goal is to engineer new functionality once and reuse it in all of those product variants that shall include it. Assets that are not part of all variants are mapped to features held in a feature model. So this is represented by this green arrow you can see here between feature model and 150% engineering assets. Also, the feature model holds information about interdependencies between different features. So what can be used in combination in a product variant, what conflicts each other. Based on that feature model, variants can be configured by selecting features in a so-called variant description model. In a transformation, Pure Variants takes these informations as an input and generates the subset of assets for each variant that is needed for the respective variant. So we are talking here about automated reuse. So these assets that I'm talking about here include system requirements, software requirements, system and software architecture, board design, test cases, code, and other assets. So that's in a nutshell what Pure Variants provides to its users. Besides that, Pure Variants provides a lot of added value around that approach, like automated update capabilities for generated variant-specific assets that have been locally changed after such a transformation, and after a while need to receive an update from these 150% assets without losing the locally made changes. So you see there's a lot of additional functionality included, and all of it requires that Pure Variants is well connected to a lot of other engineering tools from different domains in order to achieve such a holistic reuse approach. And by now we have here more than 40 different in-tool integrations out of the tool integrations out of the box to many different engineering tools. With Pure Variants 5, we introduced new tool integrations, for example, to the ECAD tool Suken CR8000. And we added strong support for OSLC to enable our customers to include stakeholders from additional domains in the product line engineering workflow and thereby help them increase their engineering efficiency. So let's go through these OSLC capabilities one by one. So first of all, support for OSLC capabilities is not completely new for Pure Variants. Pure Variants already supported interacting with global configurations for a while. It can take a global configuration that holds superset engineering assets of different types in itself, including, if you want, also already the Pure Variants models as an input, and generate out of it variant-specific global configurations with variant-specific engineering assets inside. In the last release, so in the newest release, we heavily extended our support for this OSLC concept of global configurations. With Pure Variants 5, the Pure Variants model server that holds the models in a database and can be used instead of following a file-based approach to somehow get these models into global configurations, can directly provide a pure variant stream now to a global configuration. Meaning, like you see depicted here, we can now really make pure variance assets that are directly located in such a model server and run in a database, and which allows you in the end features like parallel work on a model, or also gives you fine-grained role-based access control for all of your variant management models. Can now be used in combination with global configurations, which is, I think, a big thing for many enterprise customers. Also, with regards to global configurations, we improved our support for deriving variant-specific global configurations out of superset global configurations. So earlier, you were able to hand over to pure variants one global configuration that holds multiple streams providing assets from different tools to generate another global configuration that then holds the reduced variant-specific assets out of it. At our customer sites, we saw that there are a lot of times is a need for a more complex structure. So having global configurations, consisting nested global configurations again to hold all the different engineering assets in a meaningful way. So Pure Variants 5 now comes with this nested global configuration support. So you can hand it over a nested structure, a more complex structure consisting of multiple global configurations, and a variant-specific or equivalent nested structure can be generated out of it. Then again, holding all the variant-specific assets. There's another concept that we introduced as a new core concept, as it also has a lot of impact on the way you can work with with our tool, with Pure Variants, which is the concept of partial configurations. That is not directly a OSLC capability, but can be used in interaction with what I earlier showed. It provides support for, instead of generating directly out of your 150% engineering assets, 100% variant-specific ones, just go in with multiple steps and first generate a kind of sub-product line, where already some features decisions have been made, and according to this, your solution assets like your requirements code and so on that are connected to the features are partially reduced, leaving some variation points in, and then in the following step, finish the actual variant configuration by selecting or excluding some of the remaining features, and then going to generate out of these between assets finally the actual variant specific assets. So you can really combine this now with our support for nested global configurations that even might include a stream provided by Pure Variants directly. Another topic is the topic of delegated UIs. So there we also have full support now. So as the Pure Variants model server is now fully OSLC enabled, it allows to trace features to other engineering assets via OSLC links and gives engineers easy access to variant management data from within other tools via the delegated UI. Via delegated UI, we also provide navigable links to our feature models and variant models that can now be accessed via the web browser. So here you see this pop-up is filled by data stemming directly from the Pure Variants model server provided via delegated UI here to a test management tool. And if I want, I can go into the details and click on a link to then be navigated to our new web-based UI that allows you that it exists in addition to our Eclipse client and allows other stakeholders that don't work with Eclipse to access the feature models via browser. Also, the variant models can be reached that way. So here you see the role of OSLC is to provide additional stakeholders access to our data and provide existing users, let's say, an additional easy way to access our data besides working with a client-based tool. So beside that, the actual variant configuration and review of variants can also now be done via browser. And again, OSLC makes it possible via link propagation to get from out of other tools that these roles are used to work in to this step. And this way have a more seamless way of working with a holistic variant management tool. So you might ask, which way do we connect to other OSLC enabled tools, as there is currently no OSLC definition that we could make use of to connect a variant management tool to other engineering tools. So for the moment, we expose this service as a requirements management tool would do, meaning if another tool supports OSLC and can consume requirements management related data, it can via that also have links to features, to pure variance features, and this can be used to navigate to the different functionalities I have shown here. So I hope this was interesting information for you. If you are interested in getting more information about the new capabilities of Pure Variance 5, or want to know more in more detail how what we have seen here works exactly, please feel free to reach out to us. We have material available that we will happily share with you on request, and are happy to give you detailed information in an online presentation or workshop. Also, there are multiple webinar recordings already available in case you are interested in how to apply variant management for certain engineering assets. With that, I want to say thank you for your attention. And I think there is still time left for questions. So if there are any, please feel free to ask.
Thank you, Robert. Thank you for presenting. I think that some of the viewers may be listening to the YouTube live stream, not live, but with a certain delay. So I'm expecting it will take a few minutes for people to hear your concluding remarks and ask some questions in the Q&A. In the meantime, thank you all for joining. I get information that Tarek will not be ready to present today. Persistent Unite has been presented in Persistent webinars, so I'll be posting a link to that one, just in case you really wanted to hear about Persistent Unite solution. And it was really great to hear all those presentations from the community of vendors, academics, SMEs, and of course, the users of OSLC. While I'm giving my concluding remarks, you're still welcome to ask questions, and if some arrive, we'll have a short Q&A with Robert. I invite you to join and contribute to the OSLC Open project. The easiest thing to do is just to join our weekly call on Thursday on Jitsi, and just ask whatever you want to ask, and we'll direct you to the right place. I also invite you to join and contribute to Eclipse Lyre. and help us shape our next live 4.0 release, whether it would be by filing bugs and feature requests or contributing with pull requests. And finally, you can just simply participate in the community without any obligation to contribute by simply joining the discussions on Slack and OSLC forum. All the relevant links you can find in the description or ask them in Slack. There were many questions from people during the 3 days of the event about the slides. Over the next few days, we'll collect the slides from all speakers who gave their consent, and we'll post them on the website and notify people on Twitter, LinkedIn, and Slack. The video links will also be available for you to be able to share them with your colleagues in case they were not able to join us live or were able only to join for 1 or 2 days. Now, let's see if there are any questions in Q&A. There are still 34 people, but I don't see any questions in the Q&A. So I assume that quite a lot of them were behind. But in any case, Robert, it would be great if you could join OSLC Slack. And everybody who is watching this right now, you're welcome to go on Slack and ask Robert any questions there or through the channels he announced. Thank you, Robert.
Thanks.
So with this, this was the last talk. It was a great pleasure, and with this, we're closing this event. Thank you again for joining over these 3 days, and let's continue the discussion on our weekly calls, Slack, and OSLC forum. Thank you again, and have a nice evening.